Welcome everybody to today's webinar broadcast. My name is TJ Willits with Veolia Water Technologies, and I'll be your moderator for today's event. I'm just looking at the registrants who are logging on to the webinar here. It looks like there's several still logging in. So we're just going to give it another minute or two to make sure everyone could get into GoToWebinar here before we begin. So thank you for your patience. We'll begin momentarily. And for those of you who may have just joined us, we're going to just start the webinar in a few moments. I'm still seeing a handful of people still logging in right now. So we'll just give another minute or two before we start today's presentation. Okay, we're going to begin today's presentation entitled Get Ready for Climate Change Issues and Resiliency with Actiflo. My name is TJ Willits from Veolia Water Technologies, and I'll be your moderator for today's presentation. And if we could just advance to that next slide. And everyone should be hearing me now. There are two methods to listen to today's audio for the presentation. You could use your speakers from your computer or your headphones. If you're having issues with that, there's another way to listen in, and that's by using the call-in number, and you could conference in on your cell phone or desk phone. Just another housekeeping item, your microphone is automatically muted since there's so many people with us today. But don't worry, we have a method for you to interact with today's panelists. And to explain that, we encourage you to submit any questions that you have throughout today's presentation. If you look on the right hand of your screen, you should see what looks to be like a chat box. If you have a question that pops up during the presentation, just enter that there, and we'll take a log of it and try to answer as many of those questions after the webinar. And for those of you that are on the line, you may or may not know, but today's presentation is part of several webinars that we've planned for this month. And we're winding down this series, this webinar series, but you can log on to veoliawatertech.com. We have another one, another few scheduled for this week as well, if you want to register for those, and you can see those listed there. And to access those, just visit our website at veoliawatertech.com. And in addition to the remaining live webinars that we have scheduled, we also have made all the webinars that we've done this year and even years prior available on demand. So if you want to watch any of those webinars, you can just log on to our website again at veoliawatertech.com, and you'll see the on-demand link, and you can access that content whenever you want to catch up on some of those educational webinars we had already. We're offering webinar participation certificates for anyone who joins us here today. The PDF certificate will be sent to you via email about a day or so after the event. So be on the lookout for that document to come to you. And something fun, after the webinar, all the attendees will be sent to a survey right after the presentation. It takes about 2 or 3 minutes to fill out that survey. But go ahead and do that. It really helps us improve the content that we end up putting for these webinars. In addition, there's a way to submit different ideas for future webinar broadcasts. And as a thank you, we'll put all the survey respondents into a drawing to win a $25 Amazon gift card, and you'll be notified within a few days after today's event. And one slide before we begin today's presentation, you may or may not be familiar with Veolia Water Technologies. So just a few bullet points about Veolia. Veolia is a leading water and wastewater treatment provider, and we execute our efforts along three key pillars, and that's by providing technologies, executing projects, and providing a wide range of services for our customers for industrial and municipal varieties. And without further ado, I'd like to introduce today's panelists that we have here today to share their knowledge about the topic. Our first panelist is Christian Scott. Christian is the Director of Strategic Market Intelligence. In addition to that, in connection with Veolia's Centers of Expertise worldwide, he is also the Product Manager for the Actiflo family in Canada. He graduated in civil engineering from Polytechnique in Montreal with a specialization in water treatment. And Christian Scott has also completed graduate studies in engineering project management. Prior to Veolia, he worked 11 years in consulting engineering, designing and implementing a wide variety of projects in municipal drinking water and wastewater treatments, as well as industrial processed water and effluent compliance for reuse. Also joining us from the US is Reed Staten. He is the US Product Manager for Veolia's Actiflo ballasted clarification system. He's based in Raleigh, North Carolina, and he has a degree in mechanical engineering from North Carolina State University. He's been with Veolia for over 19 years, and prior to his current role, he also was a mechanical and process engineer and process manager. He has extensive experience in product development, process engineering, and operation of physical chemical separation and filtration processes for both water and wastewater treatment. So without further ado, I'd like to hand today's webinar over to our first panelist, Christian Scott. Christian, are you with us here today?
Yes, thank you. Thank you very much for this introduction. We are living extraordinary times, but the return to normality has clearly started. But what is normality in this beginning of 21st century? Not long ago, it was clear that one of the main trends or buzzwords in the water business was how to be ready for the impacts of climate change. The cause of climate change may be debatable, but the effects are not. And as water utilities are thinking about future-proofing their plants and systems, another word comes back all the time: resilience. We will start by looking quickly at some definitions of resilience and then go through examples where a proven technology with decades of experience in North America, the Actiflo, shows its relevance for these very modern challenges. I will, after, hand out the presentation to Reed, who will present you another member of the Actiflo family, the Actiflo Carb, that can provide additional solutions to go further in that mission. Resilience. The Wiktionary will say, give this psychological definition: ability of human beings or a society to withstand a brutal ordeal and take advantage of it to strengthen themselves. What can this mean? How can we do this for a city? How can a city be more resistant to shocks, risks, particular climate change? Veolia was presented to you. Veolia has the specificity of being a company that's not only a technology company, but has a lot of operation experience since more than 165 years, being responsible for utilities in many places and operating them and sometimes even owning them. This is a very important question they had to look at. And one of the answers and one of the definitions they give is anticipating risks rather than just reconstruction, a logic of prevention, an ability to work together to make risk a growth opportunity. Water treatment utilities specifically face different challenges. We see more and more floods that have a big effect in raw water quality, increase of solids, also organic matter. We hear in the news all over the world the frequency of forest fire that are more and more frequent and important, that have the same effect. We also hear more and more about presence of algae and coming together often with their toxins. And another way where resiliency is important to take into consideration, there is more and more presence of pesticides. There is risk of hydrocarbon spills from pipelines, and the presence of emerging pollutants, endocrine disruptors, pharma, micro, and nanoplastics. And we see more and more also coming those PFAs, PFOS, rare earth. We're talking about more things that we will have to take care of in our water treatment. Actiflo is a well-known process in North America and in the world. But I will still take some time to look at its specifics and see how it can relate to the question of resilience. The main characteristics of the Actiflo technology, we know its compactness, but also its efficiency. Very efficient on a high range of conditions, and also its versatility, being efficient on turbidity, organic matter, and many other compounds. Let's take a little time to understand the technology as such. It's ballasted flux clarification. The first step, which is a coagulation tank, or sometimes even in pipe coagulation, it's where the chemistry is happening. There, depending on the quality, on the type of water, the right chemistry has to be determined, often by jar testing, by piloting, or now also by experience, so that we get creation of flux that are optimal at this step of the process. This section is where also all the versatility of the technology is happening, because any type of chemistry can be applied to the technology. We are applying Actiflo in drinking water, wastewater treatment, wet weather treatment, and a lot of experience also in mining for metals removal, softening, etc. When the chemistry in the first step of the technology has been determined and rightfully executed, then the water goes to the second tank, the flocculation tank. Here, it becomes specific. You have the addition of the microsand and the polymer. The microsand is the ballast. It is in this stage where the destabilized matter is bridged, is glued together in a strong flock, and is also glued to the ballast, so that every flock has a grain of microsand, which increases its density so that the settling after that can be happening very fast. You will notice in this flocculation tank the special device called the TurboMix, which permits to have a gentle and optimal mixing. Then the water settles very fast because of the weight of the microsand, of the ballast, and goes through lamella and is treated. The sludge and the microsand is raked to a recirculation pump, pumped to a hydrocyclone where the microsand is recirculated with an efficiency of more than 99.9%. And the sludge lighter is gone to the wastewater. The major advantages of the technology is its robustness, process stability. Because one thing I did not mention, in the maturation tank, you get a very high concentration of solids by the presence of microsand. The solids can get up to 5 to 10 grams per liter, 10,000 milligrams per liter. So if there is a variation of solids at the entry from 50 to 1,000, it's very little compared to the mass, the inertia of solids in the system, which makes the fact that it is very stable. Performance is proven to be very high in great range of turbidity, TSS, and pollutants. And also, this system has very short hydraulic residence time. First tank of coagulation is about 2 minutes or less. Flocculation, 6 minutes or 4 minutes or less. And very quick clarification. So the start and optimization of the treatment process is very quick. You start the system and you know in a few minutes what the result will be, and if the chemistry needs to be adjusted in case of a sudden change, let's say, of raw water quality. The consequence of that very short hydraulic residence time is the very small footprint. Limited space can help increasing capacity of existing plants, of existing tanks that can be rehabilitated to much higher flows and leave a space for other processes, such as sometimes ozone or additional filtration. This reduces civil engineering costs, and the process is simple to operate, requiring minimal staff attention. There are more than 1,000 Actiflos worldwide, and on this slide you will see the 435 references in North America. All, not exactly all, we wanted to show the main area where they are concentrated, but we also have references to Hawaii and very differently to the Arctic Ocean in the north, where it shows its robustness due to very cold water situations. Versatility is shown in the color of the references. You see the blue dots are drinking water plants, but other colors may show different applications in primary, tertiary wastewater or industrial applications such as food and beverage. And in purple, you will see mining applications a lot of them in Canada, and some in the far north that we don't see on this slide. When we are talking about the robustness of the process and the link to climate change conditions, one of the first, or if not the first, climate change impact I listed earlier were floods. Well, Actiflo has had the occasion to show its performance during many floods in Canada and in the United States. I put forward the example of the city of Red Deer, which is a medium city in Alberta between Edmonton and Calgary, where there were very important flooding in 2005. As you can see on this graph that shows 1 month of operation of the plant, the drinking water plant, from the 1st of June till the 30th of June 2005. You see how around the 20th of June there has been very high concentration increase and degradation of the raw water quality, bringing the raw water up to 2,500 NTU. If you look at a zoom of the clarified water quality, that typically is 0.5 NTU, it didn't go much higher than 2 NTU with no impact whatsoever in filtration. During that time, many of the plants in Alberta were shut down because of the bad raw water quality. It's just at that time that the city of Calgary decided to install Actiflo technology at its two drinking water plants of Bearspaw and Glenmore. It was I think a good thing, as here you will see there was another extreme rainfall in 2013. And on the right-hand side, you will see the water going over the Glenmore Dam. The water ahead of that dam is the raw water for the Glenmore plant. So as you see the color, the quality of that water. We have here a slide that comes from the city of Calgary, the presentation they made in conventions that we could see. It shows 13 years of raw water and clarified water quality in the Glenmore plant. So you see here in 2011 is the blue line is the Actiflo system being put on in line. Here you see the peaks, in red, the peaks of the raw water turbidity that happened in 2005. This is the flood that we saw at the previous slide in the Red Deer that went. And here you see there has been in 2013 more than 4,000 NTU on top of in the raw water. The green dots on the other here log scale show the clarified water turbidity that could go up even over 20 up to 45 NTU. When the Actiflo was online, with even the worst raw water event, the clarified water remained under 5 NTU. Another example of the Actiflo robustness due to in link with climate change impact. Wildfires. You maybe heard about 2016 Fort McMurray wildfires. Fort McMurray is the oil town for the oil sands in northern Alberta. A third of the city burned down in 2016, with a dramatic effect on the water quality. Well, not only that, everybody had to evacuate the city for a very long time, and there has been, it's the event that had the most damage in the history of Canada. Even with the raw water very much degraded, the firemen were able to operate, well, the city was able to operate at 150% of the design capacity for the fire fighting. Now we see that the Actiflo had a very good response to the dramatic increase in solids, which is one of the effects of a watershed, of a wildfire on a watershed. We also know that on the long term, also short and long term, there is an increase of dissolved organic carbon in a watershed that has been affected by wildfires. We are currently participating into a study of the University of Waterloo that is looking at the best ways to treat water after a wildfire. We have had some tests with on the solids and are looking forward to testing activated carbon to complete. These the results, the first set of results will be published by the Water Science, Technology and Policy Group at the, and you can look for that coming soon at the address on in the presentation. 2016, in Saskatchewan, pipeline oil spill at the city of Prince Albert, which is equipped with Actiflo. In a few days, the city had to change water source from north to south Saskatchewan River, with pipelines of raw water going to the plant, with a dramatic difference of quality in between the two rivers. And the Actiflo, they were able to optimize the chemistry and get the same water quality for the city during the time that the normal raw water source was cleaned up and ready to be switched to a bit later. During that time, we've done some tests, some lab tests on hydrocarbons removal, and we could validate that the Actiflo was very efficient on removing heavy hydrocarbons, because that spill was of heavy oil. However, we know that Actiflo, as any chemical physical system, or at least as at any clarification system, will not remove light hydrocarbons like Vitex. Here again, adsorption could come and help for that. Algae, we have experienced the north of Montreal very high bloom of algae in 2005 because of a dam that was spilled a sudden quantity of algae. All the plants on the river had difficulty producing the quantity of water, and some were shut down. But the Actiflo we were testing for government approval at one of those plants that was shut down had zero effect on its operation. We have many experience of testing and piloting and full-scale plants that show a very good performance on algae removal, which is similar to the one of dissolved air flotation. You can see here an experience in Florida, an example in Florida, where we see 99.5% total algae removal and 95% efficiency on cyanobacteria. One image is worth 1,000 words. Here are two. So see the raw water and the clarified water at the right-hand side of the slide. Algae removal is one thing. We also have to think when there are cyanobacteria toxins, there might be toxins coming with the algae. We know that Actiflo membranes will remove algae. We know that Actiflo and DAF have a very high water production security. Sometimes membrane may show a decrease in the fluxes, and for the worst blooms even have problems continuing functioning for some time if not attended to as they should. We also have to think about toxins that come from cell lysis. There are research showing that in sludge blanket technologies where there is a high concentration of cells, this situation may favor the lysis of cells and release of toxins. In some membranes too, there has been other studies that show that the pressure on the membrane may also favor cell lysis. Have to be very careful about this element in design. For the Actiflo, the cell will be removed through the hydrocyclone and eliminated very quickly from the system. But here again, the Actiflo will not treat the toxins for sure. So there are other processes for that. And here again, PAC and adsorption are a good solution. So this to the moment where I will pass on the presentation to my colleague Reed, who will talk to you about Actiflo Carb, which is some adsorption to the system.
Yes, thank you, Christian. Staying with that theme, in terms of resilient technologies and shifting focus, as Christian said, to Actiflo Carb. And for those of you not familiar with Actiflo Carb, it is a combination of Actiflo and all the benefits that Christian just talked about in terms of a robust, very adaptive technology, and combining that with the adsorption capabilities of powder activated carbon. Powder activated carbon is well known for its efficiency in removing things that are typically more challenging to remove through just coagulation and typical water chemistry alone. Some of that focus is on the lower molecular weight organics, algae, and especially the toxins, as Christian alluded to earlier. PAC is very adaptive in removing those toxins, taste and odor, pesticides, hydrocarbons, which Christian mentioned as well. And then powder activated carbon is very efficient in terms of emerging micropollutants as well. We talk about personal care products, pharmaceuticals, EDCs, things that are present in our watersheds that we don't like to talk about, but carbon is very effective in the removal of those as well. So how does Actiflo Carb, how does it work? How does it combine these two technologies? Again, taking PAC dose upstream, putting it through an absorption tank upstream of the ballast clarification process, including a pack recycle, and I'll talk a little bit more about that pack recycle, but it's the combination of those two that basically afford Actiflo Carb. is essentially a more effective use and a continuous removal of those compounds compared to once passed through carbon systems, where carbon is dosed, passed through the system and the process once, and then removed. So Actiflo Carb essentially combines an absorption tank and then a recycle of that carbon to fully utilize and maximize those absorption sites of the PAC. And then just like ballast declarification and Actiflo and the process that Christian talked about, those pack particles are then coagulated, they're flocculated, they're bound to that micro sand, and they're settled out quickly and efficiently, just like Actiflo, allowing for a very high throughput in terms of gallons a minute per square foot, and a very compact footprint as well. And why does it work? Actiflo Carb inventory is a very large amount of carbon. Typically, based on the application, it maintains about 1,000 to 2,000 milligram per liter of carbon within the system. And so this large inventory, along with the absorption tank and the residence time in that absorption tank, including that pack recirculation, as I mentioned, as a ballast drops out with this PAC, we separate the ballast, reject that back into the Actiflo portion of the Actiflo Carb process, and then the carbon is reused and recycled back to the absorption tank. Oftentimes, based on the application and flows, this results in a pack age within the process of 18 to 24 hours. And so again, fully utilizing all the absorption sites and ultimately reducing OPEX in terms of the required fresh pack dose needed for a given application compared to once passed through systems. And again, much like Actiflo, Actiflo Carb takes advantage of that ballasted high rate clarification. It's able to do that in very small footprint and high throughput in terms of gallons per minute per square foot, 12 to 16, or 30 to 40 meters per hour. So as mentioned, organics is a primary focus with carbon, and it's a primary focus for Actiflo Carb. When we look at organic removal, at least in the US, the EPA's established guidelines for what enhanced coagulation should do for a given watershed and a given utility. These are based on stage 1 and stage 2 guidelines for disinfection byproduct formation. And again, I think most probably have seen this or familiar with this, but it's a function of your influent TOC and your influent alkalinity in terms of the guideline for what the anticipated removal should be with coagulation alone. So then the question becomes, for my utility or your utility, what happens if coagulation isn't sufficient enough to meet my DBP? And there are a lot of factors that play into that in terms of the compounds and constituents that you're dealing with in your water source, but also your distribution system plays a large role in that. And what we've seen is a simulated distribution test, essentially quantifying the formation potential for DBP, your THMs, your HAA5s, as it portrays against TOC and effluent TOC. So in this example, 80 and 60 microgram per liter is the threshold that we're focused on, the MCL, so to speak, and then plotting that against TOC values. And for this example, in order to meet that 80 or 60 microgram per liter threshold for your DBP formation potential, you have to be, in this case, less than 2 milligram per liter of TOC. And again, this is very dependent and is going to vary from site to site. As mentioned, PAC has an affinity for a multitude of things. And what I talk about next is taste and odor and pesticides. This is a facility in Indianapolis. It is a seasonally operated Actiflo Carb system specifically for the seasonal spikes that this facility sees, primarily during the summer, early fall period with respect to geosmin and MIB. Taste and odor issues, as well as pesticides that this facility sees due to runoff. This is just showing you some of the data associated with this site with respect to taste and odor. The geosmin and MIB data here is actually a spike test that was conducted in the pilot trials prior to installation of Actiflo Carb, looking at varying influent characteristics up to a few hundred milligram per liter, and the ability of Actiflo Carb to provide a very low and consistent effluent quality as influent concentrations increase. And then also looking at the pesticides removal, various compounds, and the ability of the carbon in the Actiflo Carb to produce, 68 to upwards of 98% removal, sometimes below minimum detection limit or limit of qualification for each of those compounds. As mentioned earlier, carbon also has affinity for micropollutants. This is data from a study conducted back in 2011. It was a WRF-funded study in Milwaukee, and this was specifically focused on the ability of carbon and Actiflo Carb in its removal efficiency of pharmaceuticals in the tertiary side of this wastewater treatment plant prior to discharge. It was an extensive study looking at a number of things, but this is presenting the data of those pharmaceutical removals across both 10 and 20 milligram per liter. As you can see, at 10 milligram per liter, most compounds here were successfully removed at 40% or 50% or greater. And then as we increase the dosage of fresh carbon, again, maintaining a large concentration of 1,000 to 2,000 milligram per liter, but dosing just a small amount up front of continuous fresh carbon of 20 milligram per liter, we see those individual removal rates increase upwards of 80% or greater for all pharmaceutical compounds shown. And I would like to highlight, what if your water source is a little more challenging, whether it be high influent solids, maybe a higher concentration or a more challenging type of organic, or the combination of high TSS as well as the challenging characteristics of organic matter as well. Veolia has a solution. Typically, because of that, coagulation isn't sufficient enough to meet water quality demands, and so a two-step or a two-stage process typically is required. And this is Veolia deems this as Actiflo Twin Carb, where we look at Actiflo as primary clarification ahead of Actiflo Carb, focusing on the constituents within the watershed that is easier to remove via just coagulation alone. Turbidity, the higher molecular weight organics, color, you'll get some algae removal as well, iron and manganese have precipitated. And then this clarified effluent then passes through the second stage Actiflo Carb process. And PAC is not selective. It will try to absorb whatever's in this raw water that you send to it. And in very challenging water sources like this, you want it to focus on the more challenging compounds. In this case, after primary clarification, it now gets to focus on those challenging organics, the low molecular weight microorganics, pesticides, taste and odors, EDCs, and those micropollutants that we talked about. So it really allows carbon to do its job on the things that, say, conventional coagulation through a high rate ballast clarification process isn't as efficient in removing. And just to give a kind of a good picture of what we're looking at when we talk about Actiflo Twin Carb, these are samples pulled from a pilot where we had 2 trailers on site. We had an Actiflo followed by an Actiflo Carb trailer. This is a water source with a relatively high DOC, 14 milligram per liter, and the 2 beakers on the left identify the influence source and the resulting performance of that first stage Actiflo clarification step. Again, getting down to a DOC of 4 milligram per liter or just over 71% removal. And this effluent then passes through Actiflo Carb. The middle beaker here, the dark one, represents a sample pulled directly from the absorption tank. again, 1,000, 2,000 milligram per liter of carbon to make use of all the absorption sites and make the most use of that fresh dose that's applied upstream. That fourth beaker there is pulled directly from the maturation or the flocculation step of Actiflo carb, where those packed particles are then coagulated, flocculated, and bound to microsand, pulling a sample right out of that, and within seconds, you get a very fast, very settable flock, ultimately resulting in that last beaker there, clarified effluent out of Actiflo carb with both Actiflo and Actiflo carb, in this case, achieving that 2 milligram per liter or greater than 85% removal of DOC with this watershed. So I want to shift focus a little bit to examples where Actiflo carb has been applied. I just want to highlight the experience VOA has globally, pushing 60 total installations, over 12 years of experience globally with Actiflo carb. From our smallest installation, around 1 million liters per day or just a few hundred gallons a minute, to our largest installation, pushing 250 MLD or about 66 million gallons a day. And if we take a look at the North American references, we currently have 5 in operation, and we'll spend a little more time on most of these on the next adjacent slides here. I do want to highlight the pilot tests as well. We've done 12 to date in North America across a wide range of applications. Drinking water, typically focused on organic removal, taste and odor, algae and its associated toxins, as well as pesticides. And then when we start to look at reuse applications or municipal wastewater applications, those are primarily focused on what Actiflo carb can do with respect to micropollutant, emerging compounds, pharmaceuticals, EDCs, things like that. First reference I want to talk about is Randall Reef in Hamilton, Ontario. It's a rehabilitation project of the Hamilton Harbor, just south of Toronto. Hamilton Harbor is fed by Lake Ontario, which over the years has had a large influence of industrial discharge that's resulted in pollution of the Hamilton Harbor. This is a federally funded project focused on the removal of polycyclic aromatic hydrocarbons from Hamilton Harbor, which are essentially byproducts of burning coal and oil and gasoline. As mentioned, this is a federally funded project that they ultimately, based on the removal of dredging water pulled from Hamilton Harbor, the city led with Actiflo 2 and carb to help them as part of this rehabilitation project, focusing on not only removal of suspended solids, but also those hydrocarbons through the second stage Actiflo carb process. Taking a look at various compounds of those hydrocarbons and their associated discharge limits, this is 2 years worth of data so far. You can see Actiflo followed by Actiflo carb has been very successful at meeting those discharge limits, and in a number of cases, especially the fluorine graph here, the ability to meet and exceed well beyond those discharge limits in terms of the removal of hydrocarbons. Switching focus a little bit to a few U.S. installations. The first one being Nashville, Tennessee. It's a 23 MGD or 87 MLD Actiflo carb facility as pre-treatment to microfiltration membranes. As a result of it being pre-treatment, there is an intermediate filtration step that includes Hydrotech, disc filters, 10 micron, woven cloth media as an intermediate filtration step prior to these membranes. Actiflo carb is seasonally used in Actiflo carb mode. And when I talk about Actiflo carb mode, one of the benefits of carb is you can transition between Actiflo in terms of ballast clarification and high rate clarification and Actiflo carb. So this facility, especially in early spring, will operate as needed in Actiflo mode. And then starting late spring through fall, transition into Actiflo carb mode and operate pretty much 100% of the time in Actiflo carb mode. And its primary focus is removing those constituents that they see seasonal spikes in that are prone to create and have challenges from a membrane perspective. We talk about organics and DBP formation, but also mostly focused on taste and odor, and then they do see seasonal spikes in algae as well. Taking a look at a relatively typical season for Nashville and their water source, as mentioned, Actiflo is direct clarification, so there's no upstream clarification step. When they transition into Actiflo carb, because it is the combination of the absorption step and the high rate balanced declarification step, Actiflo carb is essentially a clarifier. And so not only is it great at removing compounds that are more challenging and maybe require absorption to remove, but it's a clarifier and will also remove the suspended solids as well. So Actiflo carb, especially during this summer to fall period of time, we'll see spikes in influent turbidity, and this graph is just representing that variability in this source water for this given facility and its ability to meet not only organic removal and help them with DBP issues and eliminate the membrane fouling potential with taste and odor and algae, but also handle those turbidity spikes and provide a very consistent, clean, effluent quality prior to membranes. Taking a look at another facility in Central California, the West Hills Water Treatment Plant. This is a district that's pretty much predominantly focused on groundwater. They had an increase in demand, and we're looking at alternative ways to limit their impact on their groundwater wells. So they shifted focus to two local reservoirs, San Luis and San Justo, for their expansion plant. Both these surface waters were challenging in terms of TOC. They're prone to, manganese and iron challenges at various periods of time, but also bromide, which made it very challenging in terms of DBP formation. It was an extensive upfront effort with their consultant, HDR, to look at both source waters at different times of the year. They did a lot of jar testing and pilot testing to quantify what effluent TOC they needed to achieve with Actiflo carb, with their goal being 80% of their MCL, so 80% of the 80 and 60 microgram per liter. And based on the pilot and jar testing, they arrived at needing to meet 1.2 milligrams per liter for effluent TOC to ensure they meet their disinfection byproduct formation. This plant was commissioned in 2017. This is the first few months of operation on the following year. Just looking at, again, the effluent TOC, or I'm sorry, the influent TOC in blue, and then the corresponding effluent TOC. Again, Actiflo carb successfully as a direct only clarification step, treating directly off these reservoirs, meeting that 1.2 milligram per liter that they targeted to ensure that they meet DBP. And then wanted to focus on another facility. This one is in the western coast of France. It's not the La Roche water treatment plant. Very challenging water source, and it's the reason we wanted to highlight this. You can see the variability that they see. It's fed by two different rivers, very turbid, prone to not only turbid spikes in terms of solids, but also TOC, upwards of 20 milligram per liter at times. Also prone to high iron and manganese, very challenging source water. And then they have runoff as well that is prone to seeing spikes in pesticides. And given all this, and to meet the city's goals, they actually they chose to proceed forward with what we call the Actiflo Twin Carb, which again is Actiflo as primary clarification, followed by Actiflo carb. They chose pre-ozonation just upstream of the Actiflo, again with the focus being on those constituents and compounds that can be removed through coagulation. So TSS, high TSS and this variability that this two water sources see, the metals in combination with the ozone, the color, to provide a good initial clarification and allow the second stage Actiflo carb process to focus on the more challenging compounds, the low molecular weight organics, the pesticides, and really allow the most advantageous use of that fresh packed dose upstream on those conditions that are difficult to remove through coagulation alone before this water quality is then sent to sand filters and UV disinfection. Taking a look at some of the organic carbon that they see, again, 2 different water sources, 2 different rivers, variability, high variability in those organics, upwards of 10, 11 milligram per liter, and the ability of Actiflo followed by Actiflo Carb to help the city successfully meet their ultimate goal, which is around 1 milligram per liter of TOC. And then in conclusion, just to kind of wrap things up, I know we're running a little bit late on time here, but climate change is difficult to predict. It can and will likely lead to unforeseen challenges with raw water sources. As Christian mentioned, this can come in a variety of ways: flooding, forest fires, and associated variations in suspended solids and DOC content. It could be also agricultural runoff as well. Veolia can help. I think that's key here, that we can help. We have the experience, we have the proven and robust technologies with Actiflo and Actiflo Carb to help utilities be more resilient and adaptable to these changing conditions. And with that, I thank you for your time. And TJ, I think we open up for questions.
Great, thank you so much, Reed. Just a reminder, if you have a question, we received a few already, but we might be able to take some time to get to a few more. You'll see on the right-hand side of your screen there, you could enter in your question on the panel. And as I mentioned, try to get through as many as possible. If we don't get to your question, or if you want to reach out to one of our contacts immediately, you can see on your screen we have 2 email addresses that you could reach out, and someone will be back in touch with you to make sure you get the information that you need. A handful of questions just to start off here. Christian, can you talk a little bit about the TSS concentration levels, and what are the ranges or the max levels for TSS to make sure that Actiflo could perform accurately?
Yes, we have, as I have shown in some of the slides, we have had some experiences with very high TSS for river. We've seen the example like in Calgary Glenmore at 4,500. This is something that typically the Actiflo will be able to handle. What we just need to know, and we know when we design the system, that how high the peaks we need to expect, because the recirculation system is designed in consequence so that the hydrocyclone is able to handle that level of solids. Here, our experience also gives us some indications on that part of the design, because we know that the different sludges will be differently reacting depending, let's say, of their nature. Are they more of organic? Is there more organic content or more mineral content? We've seen even applications in mining industry where the TSS is only like silt or silt-like or clay-like minerals, and we are able to handle up to 10,000 milligram per liter TSS. But this is a very specific industrial condition. But in municipal conditions, as we see, we can go very high at that level.
Great, thanks. Reed, I have a couple questions about Actiflo Carb, and I'm just going to give them both to you now, and perhaps you could comment on it. But does the Actiflo Carb require higher coagulation dosing? And the follow-up question would be: do you have a way to do a ZLD treatment for that waste stream from Actiflo Carb?
So I think the first question is, can you repeat the first question? Sorry.
Sure. Does Actiflo carb require a higher coagulation dose?
Okay. Perfect. So the coagulant dose associated with Actiflo carb really would not be any different than traditional Actiflo. It's a function of the solids coming in or the compounds that you're trying to remove. You know, in most cases, especially when you're dealing with Actiflo carb as a primary clarification step, the coagulant dose and demand will be focused on what can be removed through coagulant, and then allowing the carbon to focus on the things that can't be. That require maybe absorption and means for better removal through something beyond coagulant addition. So the coagulant demand really should be no different than what the chemistry of the water requires. And then I think the second question was the ability for ZLD to treat the waste stream.
Exactly.
I don't have a lot of experience with that here in the U.S. The waste stream with Actiflo carb is going to be concentrated due to the amount of carbon that and solids that we maintain within the inventory. Upwards of a few percentages in terms of TSS and percent solids of that waste stream. There should be nothing about it that couldn't be treated from a ZLD perspective. But Christian, do you have potentially an experience in Canada on that?
No, not specifically on the Actiflo carb. No.
Okay. And that is something I can take a look at more in depth and reach back out and follow back up on that question as I dig more into it.
Okay. And a question about, will the Actiflo handle emulsified oils? Christian, is that something you could comment on?
Emulsified oil. It's a question of chemistry. As a matter of fact, if we can coagulate it and flocculate it ahead, then the Actiflo will handle it. But I don't have specific experience in that case, though. Sorry.
Okay. Just another question. I'm going to read it. Perhaps you might know what it is, but what log reduction credits does Actiflo provide in drinking water treatment?
Good question. Christian, I'll jump in, and
Yes.
Your experience in Canada, it may be a little bit different, but in the U.S., most states look at Actiflo no different than conventional clarification in terms of the log removal credits that that state applies to conventional coagulation, flocculation, and clarification with conventional systems. Actiflo is looked upon as achieving the same thing from a state regulatory perspective. Obviously, through pilot trials and full-scale performance data, we've shown the ability to do much greater than that, upwards of 2 a log. But from a state perspective, most of them, even with the data, don't look at it much beyond what they've applied to conventional clarification.
And it is the same approach in Canada. Canada is much aligned on the EPA for that. And this is the way the logs are treated in Canada too. Yeah.
All right, a question for you, Reed, as well, related to the Actiflo carb. But is the volume of sand required in the Actiflo reduced with the addition of the activated carbon?
Good question. Sand concentration and the size of the sand too, to that effect, is often dependent on the process and what you're trying to remove and the inventory of solids that you're essentially maintaining within the process. Typically in our experience, it's a wide range of sand concentrations that carb can operate at, but given the inventory of carbon that you're maintaining within the system, typically it likes a little bit larger concentration on the larger side, but we've operated Actiflo carbs down around 5 gram per liter of sand, upwards of 15 gram per liter per sand. So it's very flexible in terms of what it can handle in terms of sand concentration to minimize operation and impact for the operators.
Okay, another question we have here, and it refers to the use of Actiflo during a cyanobacterial bloom. What happens with the cyanobacteria cells in the hydrocyclone when separating out the sand? Will these cells lyse and release toxins? And if yes, will these toxins be recirculated within the sand in the raw water?
Yes. Okay. Go.
So the separation device, the hydrocyclone, there's no mechanical moving pieces. It essentially uses centrifugal forces to separate the sand, the heavier sand, from the sludge. In this case, the cyanobacteria as well, and the return is just microsand. It's very clean, and it's just the recirculation that bows back in. I've not seen any data to support that there is shearing of the algae to release those toxins. But if there is any shearing of those, I would expect those to be discharged away with the sludge out the top of the cyclone and not recycled back into the process.
Okay. A question for you, Christian, is talking about retrofitting. Is it possible to convert conventional Actiflo to an Actiflo carb?
Yes, it is. Yes, because as you've seen in the presentation, the Actiflo carb is a conventional classic Actiflo with a PAC contact time ahead. So that tank ahead needs to be built. And also there will be modifications to the recirculation system. The hydrocyclone could be different, and also because of the percentage of recirculation. So there will be some modifications to that recirculation system, plus the addition of the contact time ahead, which is a tank ahead. Yes.
Okay, and just one final question that we have here is, how does the performance of Actiflo carb compare versus membrane ultrafiltration UF?
Well, here we are talking about different things. Yes, we can expect that through that you will get an optimal performance through membranes, but membrane remain a filter. And what has not been coagulated and remains soluble will go through the membrane. How small the pores, if we're talking about UF or MF. So if it's to say that there is no difference of performance, there is, because of the adsorption which is not present in the UF membrane. So it would it's not the same level of treatment.
Okay, well, that's it for our questions. If there is an additional question, feel free to reach out to one of those email addresses that you see on your screen. Also, just one final reminder, again, you'll be given a survey, a chance to fill out a survey right after today's webinar. Please take a few moments to go ahead and do that, and we'll enter you in for a drawing for a $25 Amazon gift card. I'd first like to thank both of our panelists that spent their time today preparing the presentation and sharing their knowledge with all of us here online today. And lastly, I want to thank everyone who took an hour or so out of their day to learn a little bit more about the technologies presented here today. So again, if you have any other questions, feel free to reach out to any of the panelists or the emails on your screen. And I just want to wish everyone to have a wonderful and safe week. Thank you so much. Take care.